Unit 2, Lesson 1, Quadratic Functions. Well, we're first going to start by looking at two equations that are not quadratic. They are linear equations. And I know this because each of these equations has degree 1. That means the highest value in the exponent position on a variable is 1. That also implies that there will be at most one solution. So you can see here I showed us an example of how to solve here. We're going to do PEMDAS backwards. So I'm starting at the bottom. Which side has the variable would be the left side of this equation. Is there any adding or subtracting in order to isolate the x? There is. What's opposite of subtracting would be adding. And then what's opposite of multiplying would be dividing. Now at this level of math, there's something that's called an extraneous solution. And an extraneous solution arises when you do all the math correctly, you get an answer, but then when you plug it back in, the left side doesn't equal the right side. So moving forward, at this point moving forward, we always have to check. So we can do some mental math here. 2 times 8 is 16. 16 minus 6 is in fact 10. This is a solution. I'm going to go through the next example a little bit quicker. So I'm going to subtract 5 from both sides. And then how do I remove this 2/3? There's a couple ways we can do it, but I'm going to multiply by the reciprocal. And the reason why I'm doing that is because I often see students, especially at the beginning of the year, when they forget some of these basics, that when it comes time to simplify this, they want to take the -6 times 3 and then the -6 times 2. This number here will have a 1 underneath. So -6 times 3 is -18, 1 times 2 is 2, and -18 divided by 2 is -9. Now we do need to go back and make sure, and you can use a calculator to do this. Unfortunately, I did not bring one home. We need to make sure that when I plug in -9, and then I multiply by 2/3 and add 5, that I do get a -5. So let's do that right now. I have -18 over 3. Well, -18 divided by 3 is -6, and -6 plus 5 is in fact -1. It works. The next two equations are quadratic functions. So quadratic equations can consist of both functions and non-functions. In this chapter, we will only work with quadratic functions. So they're equations that are also functions. They would pass the vertical line test. So let's go ahead and solve this. These are some easier forms of quadratic equations to solve for. So I'm going to start by isolating that x squared. I know that these are quadratic because they're both degree 2. Again, that means the exponent on the variable is as high as a 2. All right, so I have x squared equals 16. Opposite of subtracting is adding. The opposite operation of squaring is the square root. Now here's again, like I shared up here, where a lot of students make this mistake of how do we simplify it? Well, here's a common mistake. This tells us there's going to be two answers, both a positive and negative. The square root of 16 is 4. So when I check this, I need to check both 4 and -4. Let's do some mental math. Let's start with positive 4. 4 squared is 16. 16 subtract 4 is 12. Let's do -4. -4 times -4. Well, negative times the negative is a positive, is still positive 16, and 16 minus 4 is 12. Moving on to our last example on this page. I'm going to move through this just a little bit faster here. So opposite of adding is subtracting, and as I did in example number 2, I'm going to multiply by the reciprocal. I have x squared equals 36 because 18 times 2 is 36, 1 times 1 is 1. I know 36 divided by 1 is 36. This tells me I'm going to have two answers, and the two answers in the form are positive and -6, but I do need to go back and check. Let's start with positive 6. 6 squared is 36. Half of 36 is 18. 18 plus 6 is 24. Also, -6 squared, well, -6 times -6 is a positive 36. Half of positive 36 is 18, and 18 plus 6 is 24. They both work. Let's move on to our second. Now, what I move into in this video is I'm going to show you 3 different ways that we can solve quadratic functions, or quadratic equations. As I said, when we look at them in terms of an equation where y equals, for instance, y equals x squared minus 6x plus 8, it would be a quadratic function when we graph it. It's going to pass the vertical line test. Right now, we're just solving quadratic equations, and there's 3 different methods. You do have to know how to use all 3. This is very important. You put this down in your notes. The factoring method is probably the most recommended method. You learned how to factor freshman year. Maybe you didn't master it. You saw it again in Algebra 3-4. And now we're expected to master how to factor in pre-calculus and calculus and moving forward. Not all equations are factorable. And so we'll learn what to do when we see an equation, we need to solve it, but factoring doesn't work. There's also multiple ways to factor. Just know that you don't get to use your calculator as you go through much of this, because half of your AP exam you can't use a calculator for. And so I will prepare you for the type of problems which require calculators and the type of problems that require you to do the algebra. Let's get started. So I'm going to teach here using a method that's often seen at the freshman level. I'm going to take what's called the A value. This is your A, this is your B, and this is your C. And if you have another method to achieve this without using a calculator and you can consistently get it right, use your method. Okay, so how do I do this? I take the A times the C, so 1 times 8 is positive 8, and then right down here I'm going to drop down whatever the B is. Remember to keep the symbol with it. And so I'm going to ask myself, what two numbers multiply to give me a positive 8? They multiply to give me a positive 8, and they combine to give me a positive 6. So I'm not always going to do this, but for right now, I'm going to write these out. So -1 and -8, or 1 and 8, 2 and 4, or -2 and -4. I'm just showing you my thought process. Now, which one of these combinations, if this is factorable, can achieve a -6 when combining it? It would be -2 and -4. Now, there's a bunch of different ways you can go about doing this, and I'm actually going to demonstrate to you just one way today. As we move through this unit, I'll show you another way that's kind of a shortcut. Okay, this is the way that's most often taught. We're going to put down the A, so this is my A. I leave a big space. I'm going to put down the C. Now, what goes in the middle? What goes in the middle is exactly what we selected. We selected the values -2 and -4. Those are the combinations that multiply to give us a positive 8 and combine to give us a -6. Behind each of these values, I do need to include an X. And now I'm going to use factoring by grouping. You learned that in Algebra 1, 2. You go through it again in Algebra 3, 4. And so we're going to move through this quickly. What can I factor out here? I can factor out at most a 1X. Now what am I left with? So I'm saying to myself, 1 times what value is 1? 1. X times what is X squared? X. 1 times what value is -2? -2. And X times what is -2X? Well, I don't need to add anything else here. If I distribute, I get 1X squared, perfect, and -2X, perfect. Now, whatever is here, I want you to pretend it's like a computer, and you're going to copy and paste exactly what is in parentheses off to the right. I'm going to put a really light question mark. And now I'm going to select what value times 1X is a -4X. That is -4. -4 times 1X is -4X. And this is the correct value if I can take it times the back value and I achieve the C. So -4 times -2 is positive 8. Again, I'm going through this as if you've forgotten, but I know this was taught in Algebra 1, 2 and Algebra 3, 4, so it should be a review by seeing these problems. What do I do in my last step? I look at both the left and the right, and I can see they have exactly this part in parentheses, so I'm going to write that down one time. And then I say to myself, what's in front of the first parenthesis? 1X. What's in front of the back parenthesis? -4. And again, I'm setting it equal to 0. Now, each of those parentheses, I'm going to set equal to 0 and solve. It seems like a lot, and it seems like I'm going quickly if you did not master this freshman year or again during Algebra 3, 4. I'm adding 2 to both sides. I'm dividing by 1. X equals 2. I'm adding 4 to both sides. I'm dividing by 1, and X equals 4. Remember, at this level of math, we have to do that mental math to make sure that they both are answers. So sometimes only one is the answer, and the other one is what's called that extraneous solution. So it's like a sneaky answer. You did all the math right, but it doesn't work when you plug it back in. Let's try 2. So 2 squared is 4, and I'm just going to do the math over here, the mental math. If I had a calculator, I definitely would use the calculator. -6 times 2 would be -12. And then plus 8. And this has to equal 0 if this answer is correct. Let's check. 4 minus 12 is -8, -8, and positive 8 is 0. This works. Let's go to the next one. Positive 4, 4 squared is 16. -6 times 4 is -24, plus 8, and it must equal 0 if this is the correct answer. 16 minus 24 is -8, -8, and positive 8 is 0. It works. So, in the next video, which you will watch today, we're going to go through more problems that involve just factoring. Remember, not all quadratic equations can be solved by factoring, but it is the preferred method. Let's look at method. Method number 2 is the quadratic formula, and it always works. So why don't we use it? Well, the reason is because quadratic formula, it's just a lot more work, but it will work to solve every quadratic formula. So let's go ahead and let's do this. What do we do first? We first identify what is the A, what is the B, and what is the C. A common mistake is students forget to bring down the symbols, so +1, -6, and +8. Then I'm literally going to drop them into this equation, which you will have to have memorized. I know some of you started to see this in 8th grade. And as you get into this upper level math, what changes is you're now accountable for the math that you were already taught, whether you mastered it or not. So I will always try to take a little bit of time to dive back into the math that you were previously taught, and hopefully that enables you to remember that. Okay, let's drop in here. Let's go with B. So I have a -6. I'm going to put in these two places. Here's a -6 and a -6. Now A is going to be in the top and bottom. A is a 1. A is a 1. C is going to be in back. And let's go here. Remember, 2 negatives equal a positive. So do you have to show all this work? You do have to show this work. Now, I'm okay in this part with you using a calculator. I obviously did bring a calculator home, so I got to do the math off to the side. -6 times -6 is 36. I'm going to bring down that subtraction sign. 4 times 1 to 8 is 32. So 36 minus 32 is 4. 2 times 1 is 2. Now, I know the square root of 4 is 2. So you'll learn as I go through this. I like to try to be efficient. Efficient is a nice word for lazy, but still getting the answer right and doing enough to show all of the work. And so as I go through this, I will always say, like, hey, here is the minimum you have to show in order to get credit. And all I'm preparing you for is, again, is going to be to pass that AP exam. And so if I mark things wrong because you're not showing enough work, it's because I'm trying to prepare you for that exam. So, you ready? Efficiency. Mathematicians like this because instead of doing this whole problem twice, one time we'd add and then we'd do the whole problem again and subtract, we're like, we're not going to do that. We're going to do it one time and put a plus or minus in between. If that's confusing you, that means one time you add, it doesn't matter which one you do first, and the second time you subtract. Here we go. 6 plus 2 is 8. 6 minus 2 is 4. 8 divided by 2 is 4. 4 divided by 2 is 2. Now, we're going to be a little bit lazy here, and here's the reason why. I'm going to save us some time. Notice that I'm showing you, to begin here, I'm showing you the exact same quadratic equation for method 1 and for method 2. So in method 1, I was able to achieve the answers of 2 or 4, and I checked them to make sure they were not extraneous. And for that reason, I'm not going to waste your time and go back and check 4 and 2 again. I know they work. The third method is called completing the square. And completing the square is taught in Algebra 1-2. It should be taught in Algebra 3-4 by your teacher. And it's often the most confusing for a student. And it's one of those type of procedures that for a lot of students, you got to do it multiple times in a row, and then it begins to click. Now, I will put you at ease that after this unit, we're going to see it a few more times this year, but it's not going to be critical really to you finding great success in this class. It will be for your next test and a few tests to come. What will be critical is that you know how to use method 1 and method 2. Now, how do we go about completing the square as a method to solve this quadratic equation? The first step is notice that our leading coefficient is 1. We want to have that. Second is we're going to take whatever is this constant. It's the value that has no variable, and we're going to move it to the other side. So opposite of adding a to subtracting a. And now I have that empty space where once there was an 8. The second step is to take whatever this b value is and remember the symbol, and I'm always going to try to teach you the tricks to do it a little bit easier. So we're going to take the b value and write it down in parentheses, and we're always going to divide it by 2. And then we're going to square it. So here we go. -6 divided by 2, well, that is -3, and then we're going to square it. And whatever we get for an answer is going to go right in here. Now, little trick here. Whether it's negative or positive, if you take a +3 and you square it, well, 3 times 3 is 9. And if you take a -3 and you square it, -3 times -3 is also +9. So the value may change, but the symbol right here will always be positive. So +9. Now, the long way of doing this would be like, oh, okay, now we're going to use factoring, and I want you to factor, and we're going to figure out how to solve this. I've got a shortcut for you. Here's the shortcut. You're always going to put a parenthesis with the square, and we're going to set it in this case equal to -8. And then inside of here, on the left, we're going to put an X. On the right, we're going to take whatever was in that parenthesis, and we're going to drop it down here. So negative 6 divided by 2 is negative 3. Okay, so we are ready to get going here, and now we need to solve this. Before I move it up, I just realized one thing. Do not erase this. Do not erase this. Let me just take 1 second here before I show you my mistake. I want you to look at this. If I told you to solve this very simple algebraic equation, and I said, please solve this, all of you would feel confident to say, okay, I'm going to subtract 3 from the left and subtract 3 from the right. Because you've been programmed at this point in your math career that whatever you do to the left, you also do to the right, because you have to keep the equation balanced on the left and the right. Well, here's where I made a mistake. I added 9 to the left, and I forgot to balance it. So whatever value goes here, I have to keep the equation balanced. So I added 9 here. I must add 9 also to the right. Now it is balanced. X minus 3 squared equals positive 1. How do I solve this? Well, I'm ultimately trying to isolate the x. So to remove the square, opposite of a square is a square root. Notice that when we have squares, if I look back to my very first page, I'm going to have two answers generally. Sometimes there's cases in which you have the same answer twice. And so how do we get the two answers? It's going to be a plus or minus in front of that square root. The square root of 1 is 1. And then I will add 3 to the opposite side. Now this is natural. Students go, where do I put the plus 3? Whatever value comes over last is going to go in front of that plus or minus. So it looks like this. And this goes back to where mathematicians are like, hey, we want to do this as easily as possible. We want to be efficient. I don't want to do the problem twice. So this means one time I add and one time I subtract. 3 plus 1 is 4. 3 minus 1 is 2. Now normally I would say, hey, you got to go back up here and you have to check to make sure they work and they're not extraneous. But I know I don't need to do that because we already showed you method number 1, and I had the exact same equation. We checked them at work. And method number 2, I said I didn't need to check it because it's the same equation, and the same applies for method number 3.